So, in the last class periods, we've been working with this model of a function. A times b to the x. A and b represent something, right? What is it that they represent?
X and Y.
They do not represent x and y. Which one's the y-intercept? A is the y-intercept. Where we start. What is b?
The slope.
I understand why you're saying slope, because it determines the rate of change. But what is b? When I make a table,
B is the dependent variable or independent.
we have x and y, right? So at 0, I would start at a, since that's the y-intercept. How do I determine the next number? No, we just multiply by b. This is what we multiply by. Stop the side conversations. So this would be a times b. What would 2 be? Okay, let's say I worked with a real model like this. All right, so I have at 0, I would have what? For y equals 2 times 3 to the x. I'd start at 2. And then at 1, I would go up to 6. At 2, I would go up to 18. So I multiply by 3 each time, right? So I'm multiplying by b each time. A times b times b. Yeah. Okay. So, on a graph, wherever it crosses the y-axis will be at A, and then B will determine how fast it curves upward. Okay, so last class period, we talked about compound interest. And when we're talking about percents, if I had, say, 37%, how would I convert that into a decimal? What to the left? Move the decimal. So as a decimal, this should be 0.37. So what would 8% be? 0.08. Can you open the door? What would 12% be? What would 12% be? 0.12. Good. So now, we talked about compound interest and investments. Say I make a $12,000 investment, and the bank compounds at 7.5%. How do I create a model that represents after the number of years? 12,000 goes in for what? A, okay. And then what will go in here? No. If I multiply it by 0.075, it'll get smaller. Yeah, because I have to have 107.5%. So I have 1 plus our rate. So that 7.5 is 0.075. So 1 plus 0.075 to the x. As I ran out of room. It doesn't matter where you put it. Well, it does matter with this expression because it has to end up being 12,000 times 1.075 to the x. Okay? So now if I asked you what this would be. So say I put 25,000 equals 12,000 times 1.075 to the x. How would I find that? Any ideas? No, we don't have the tools yet algebraically to solve this. So to do that, we need to use our table. So I have to put in that 12,000 times 1.05 to the x in my y equals to the x. All right, does everyone see that I did that? Okay, so now I want to know when that equals 25,000, right? So what should I go to? What? Should go to my table. So I have to just arrow down and see around when it hits 25,000. So you see this after 11 years, well, because it's compounded yearly, it would break 25,000. It would go past 25,000 after 11 years because it's compounded yearly. Okay? So the best explanation for this would be after 11 years, we will make $26,587.30. Sorry about that. Was too zoomed in. Okay, so what if I want to find out what y equals after 15 years? So what's my investment after 15 years? Go back to the table. So I just arrow down 3, and so that would be 35,000. And so our investment, y would equal $35,506.52. If you ever, after 15 years, if you ever find an investment that gives you 7% rate of return, invest as much as you can. That's really good rate of return.
What would be an
okay rate of return would be about 3%. That way it's at least not, it's at least keeping up with the rate of inflation. Okay, so the thing is, use your table to help answer these questions. That's what you've got to remember.